All right, everybody, welcome to the video here for lesson number 3 in chapter number 5. So in today's lesson, we learned about exponential functions and some of the things that happen with exponential functions. So let's take a look at number 1. Number 1 says, explain why the equation below will have no real solutions. So if I subtract 7 to the other side, I get 3 to the x equals -5. And one of the things that we learned in today's lesson was that exponential functions in this form have a range of 0 to infinity. So essentially the function f of x equals 3 to the x will have a range of 0 to infinity. Well, -5 is not in that range, therefore it's going to have no real solutions. For number 2, this is kind of a mixture of yesterday's lesson and today's lesson. So if we evaluate f of 1/2, we're going to plug in 1/2 for x. PEMDAS tells us to deal with the exponent before I can multiply, so we don't want to put 18 to the 1/2 there. We want to figure out what 9 to the 1/2 is. So 9 to the 1/2, using the rule of exponent over root, is a square root of 9. Which becomes 2 times 3, which is just 6. Number 3 asks us to graph 4 different functions here. So the first one we'll graph is 4 to the x, so that's going to start low, come up, and be really, really steep. We'll call that a of x. B of x is 1/3, so that's going to come down, and it'll cross through the y-axis at the same place. We'll call that b of x. 2 to the x is going to look just like 4 to the x. It's not going to be as steep, so it'll kind of go up a little bit differently. Notice all of them are intersecting the y-axis at the same place, though. We'll call that c of x. And the last one, 1/4 of x, is going to be a little bit less steep than 1/3 of x. So it'll look something like this. Again, still getting closer to that x-axis, and that would be d of x. This is growth, decay, growth, decay. And it also asks you to state the range and the asymptote line. All of them have the same range, which would be from 0 to infinity, and the same asymptote line, which would be y equals 0. So those last 2 questions here are the same for all 4 functions. Number 4, what is common among all 4 functions in problem number 3? Why do you think this happens? The y-intercept is 0, 1, and the reason is because any base to 0 is the value 1. All right, so if I did 3 to the 0, 5 to the 0, 10 to the 0, they're all going to give me 1. Number 5 says to algebraically determine the y-intercept. That means plug in a x value of 0. So we'll say h of 0 is equal to 5 times 3 to the 0, which is 5 times 1, or just 5. Number 6 says use your calculator to graph 2 to the x plus 3. So if I graph 2 to the x plus 3, we have 2 to the x power. New calculators, we want to get out of the exponent. Older calculators maybe use a parenthesis so we know where it ends. And then if I graph this, we'll hit zoom 6. We're probably still in a trig zoom. We notice the graph shifts up. Now, it's still going to have this asymptote line here, right? So we have to kind of take into consideration what essentially happened. We shifted everything up 3 units. So the y-intercept went from 0, 1 up to 0, 4. The asymptote line went from 0 up to 3. Everything gets shifted up 3. So what's different about this graph? Well, it's going to translate up 3. So that means the equation of the asymptote line is not y equals 0, but y equals 3. And the range is not going to be from 0 to infinity, but from 3 to infinity. Everything gets shifted up 3, including the asymptote line and the range of the function. This is essentially what we will do in the next lesson, lesson number 4. We'll talk more about the differences in the functions and how they translate and reflect and all of that stuff. Hopefully this video was helpful. I know it was kind of short, but it should have been a shorter homework assignment, and we are moving forward. Don't forget about studying for your benchmark exam and keep doing those weekly assignments. They are important and they count towards your grade. Best of luck.